Okay, I wanted to do a quick video for you to help get your feet underneath you for proofs. The thing about proofs that can be confusing is you've got to explain every single step exactly as it is. And that can be a challenge. Even I struggle quite a bit with proofs. So hopefully this video helps you understand it a little bit. As you go through proofs, you get you have to use what's called postulates or basic geometric rules and understandings. And I'll send you a link that has a whole list of these postulates and these rules so you can print it out and look into it if you'd like. But these rules are really good to kind of familiarize yourself with. As you go through these rules and these explanations, you can only use proven postulates in order to prove a case. So I'll give you an example. We'll go through a couple examples and just kind of see what's going. In this first case right here, we have given, okay? In here, in the given part, that's the only part that you can explain that something is given. If it's not given, you can't just assume that it's true, okay? So we're saying given CD is the attitude of AB. Now what does altitude mean? Altitude just simply means that that's how high the triangle is. When you deal with altitude, you say, okay, it doesn't matter what shape the triangle is. You take it from the one vertex and make it 90 degrees off of the opposite side. And you can do that with any shape. And it has to be 90 degrees. That's the definition of altitude, okay? So with that in mind, we're going to say, all right, our first statement is that line CD is the altitude, to line AB. Okay, now how do we know CD is the altitude to line AB? Well, it's right there. We're not assuming anything, it's given. Okay, and you can only do one thing per line. So next, I want to just state that the other one's the altitude. So AE is the altitude to line BC. And that also is given, okay? Because it's listed under the given, or it's told to us directly, okay? Now with both of those being given, now we look and see, okay, what can we tell from that? Well, like I was saying, the rule of altitude says that this has to be a right angle because it tells us how tall that particular triangle is. So if I were to turn that and say, okay, how tall is that triangle? Well, that triangle is as tall as that line right there, DC. But that makes that 90 degrees right here. Same with if I did a triangle right here, trying to see how tall it is, that would make that a 90-degree angle. So we can tell that angle D and angle E are right angles. Okay, and I'm just going to draw the shape there because I don't have room. I'm writing too big. But, you know, that just means they're right angles. Well, if they're right angles, we know that because of the definition of altitude. Okay, we know that because the definition of altitude says that those are 90 degrees because it measures how high it is based on the opposite side. Okay, well now what does that tell us? Okay, well that tells us that this triangle, ADC, is a right triangle because if that's 90 degrees, then we know that triangle ADC is a right triangle. And how do we know that's a right triangle? Well, the same way we knew that those were right angles, the definition of right triangles. Okay, by definition, one of the angles is 90 degrees, so that makes it a right triangle. Okay, same thing for triangle, CEA. It's also a right triangle for the same reason. Okay, now, what does that tell us? Well, if we look at line CD and AE, okay, we can see that this triangle and this triangle are similar or congruent triangles. Okay, they're congruent, and we know that they're congruent because of that right there. It's given. So we're going to say line CD is congruent to line AE, and that is given. Okay, with that in mind, we look at, all right, AC and AC. What does that mean? AC and AC. Well, that's the base of two triangles, actually three triangles if you look at it. There's that triangle, and that triangle, and they all have that same line, but we know that those are congruent sides or congruent lines because of the reflexive property. Okay, so reflexive property of congruence. Okay, if it's the same line, then it has to be congruent. Okay, how does this help us? Well, that tells us that triangle ADC and triangle CEA are congruent. And triangle CEA are congruent. We know this because of the hypotenuse leg postulate. Okay, they both share a leg, and the hypotenuse, we've already been told, is congruent. So if the hypotenuse is congruent because of reflexive, and the leg is congruent because it's given to us, that means hypotenuse leg, they're exactly the same triangle. They're congruent. Well, if we know they're congruent, that tells us that angle BAC has to be congruent with BCA. Okay, let's look at that and see why. BAC and BCA, once again, with this being congruent angles down here for these two triangles, if we extend it further out for the bigger triangle, they have to be congruent angles too. And we know that because of corresponding parts to congruent triangles. Okay? Corresponding parts to congruent triangles. The angles are corresponding parts, and so they're congruent triangles, which means they have to be congruent. And I know that's hard to wrap your head around. And finally, that tells us that triangle ABC is isosceles. And we know that because isosceles triangles, by definition, have a pair of congruent sides. So with the pair of congruent sides, we see that they are indeed congruent or isosceles triangle. Okay, now let's move on to case 2. And this one I'm just going to put the answer key up. I've typed up all these cases and all these answer keys so that you can go through them and kind of see what is going on, what's happening. And I will include these in the email I send to you with a video link. In this case, you look at it and you say, okay, what's given? We're told these things are all given. Okay, and only those things are given. We know that A AB and CD are parallel lines, and that DC bisects ADE. Bisecting an angle means that angle and that angle are going to be exactly the same. So now we know what we're saying, and we've got to say, okay, how do we prove ABD is an isosceles triangle? Well, we know that AB and CD are given, and we know that DC bisects that angle. That's also given. Okay, so step 2, that tells us that ADC is congruent with CDE. We know that because of the definition of an angle bisector. Like I said, when it bisects, it means it cuts it exactly in half. And if they're congruent, that means angle CDE is congruent to ABD. Okay, so CDE is congruent with ABD. How do we know that? Because they are corresponding angles. See, we have this angle here and this angle here. Okay, so those have to be corresponding. Remember, these are two parallel lines cut by a transversal. Okay, now if we go on to BAD and ADC, BAD and ADC, we know that those are also congruent because they're alternating interior angles. So right here and right here. Okay. Now, as we keep going, we see BAD, ADC. So you can see that it's going through and using each property of congruence, okay, and then ultimately gets to the end. And that's the key with proofs. You've got to go through step by step and try to show everything you can. It's very complicated. I'm going to send you links to some videos that will help. I'm going to send you the links to that list of postulates. I'm going to send you these proof cases with the answer keys so that you can look at them and say, hey, that makes sense, or that doesn't make any sense at all. Step by step, you just go through and prove each tiny little piece. See if this helps any, and let me know.